All right, we are given this diagram, and it is said that TS is the diameter of the circle. This is our TS, that is the diameter of the circle, and OS is parallel to PN. OS is parallel to PN. So this is the information that we have. And TO bisect angle STP. TO bisect angle STP, which means this angle is being bisected by this line TO. So that means if we would have X here, we would be having X as well in that angle. Now, what is it that we need to prove? We are to prove that PUNK is a cyclic quadrilateral. So let me just highlight this. PUNK, is a cyclic quadrilateral. So having this quadrilateral, to prove that it is cyclic, you can pause the video and try it by yourself. Otherwise, let's just then go into the solution of this proof. We know that, let me just give some things that we need to get in. We need to first remember what makes a quadrilateral to be cyclic. It's either the exterior angle of a quadrilateral is equal to the opposite interior angle. If that is the case, this quadrilateral is cyclic. Or the angles from the same segment, like we also have this one, if it is equal to that one, or if we have this one, if it is said to be equal to that one, or the last pair could be could be this one and that one. So if these pairs of angles are equal, then therefore this PUNK would be a cyclic quadrilateral. Or maybe if you have the information for the opposite angles of this quadrilateral, if they are said to be supplementary, then therefore this is gonna be a cyclic quadrilateral. So what is it that we have now? If you want to give it a try, you can start and pause the video. Otherwise, if you want to go with me, let's begin. Here we are having the diameter here. Diameter ST is a diameter, and we also know that the diameter always subtend 90 degrees at the circumference of the circle. So which means U1 is equal to 90 degrees. And also we have this other one, which is K1. Also K1 is equal to 90 degrees. So because PUS is just a continuous straight line like that, so which means U3 plus U2 also is equal to 90 degrees, which means this one also is equal to 90 degrees, because these are the angles on a straight line. And of course, if this angle is equal to that angle, so, and this is the exterior angle of a quadrilateral, and it is equal to the opposite interior angle of the quadrilateral. So on that note, because the exterior angle is equal to the opposite interior, this PUNK is gonna be a cyclic quadrilateral. Done with this proof, which is number one. Let's come to number two. Number two, we just need to be able to use the information that we have already got, so that you don't stuck in the middle. So we are to prove that SO is a tangent to a circle KUST. KUST, where is KUST? KUST. So this is these are the points on the circle KUST, which is the very same circle that we've been dealing with. Now we are to prove that SO is a tangent to this circle. So the idea, we just need to remember the tan chord theorem, which is going to be the converse now, because we are not given the tangent, but we are given the information to show whether this is a tangent or not. Now, when you're having this line OS, and you can see that in this circle that we are talking about, US or USU is the chord of the circle, and minding that this is the angle between the tangent and this line that we are to prove that it is a tangent, then therefore we also have the angle subtended by the very same chord at the circumference of the circle, which is T1 in this case. And now you just need to find out how does S1 being equal to T1, because they have to be equal. Once they are equal, which means that's the converse of tan chord theorem. Now, what are you going to do? You will remember that S1, which is this angle, let me just rub everything. This angle S1 is going to be equal to this other angle here because of alternate angles. These lines are parallel to each other. Remember the information that is given. So we are having that one. So these angles are equal to each other. So how can this be equal to the other one? So having that one, we have that information. So on that note, we are having what? We are having this angle. Which angle when we talk about? We can talk about this angle. We can talk about this angle. This angle is equal to that angle. Is equal to that angle. Reason these are the angles from the same segment, which means same segment or from the same chord SU or US. So US is subtending K2 and also subtending T1. So that is why these two angles are equal to each other. But both of them, all of them, because K2 on its own is equal to P1, whereas P1 was equal to S1 due to those reasons for alternate angles. Now, what are we having? We have K2 being equal to T1, and they are both equal to P1, while P1 has been proven to be equal to S1. So all this link, it tells us that this angle here is also going to be equal to that angle. So once you see that there is an angle between the tangent, between this line and this line, that you are to prove that it's a tangent, if it is equal to the angle subtended by the very same chord at the alternate segment, then therefore it suggests that this line OS is a tangent to this circle. So the idea was to prove that the angle between the chord and this line is equal to the angle subtended by the very same chord at the circumference of the circle. Once this angle being equal to that angle, that is what we were proving. So this OS now, after we have done all this proof, is now the tangent to a circle KUST. Now, let's move to the next question, which is we are to prove that POST, which is just post, is the cyclic quadrilateral, is also a cyclic quadrilateral. Let me just highlight this quadrilateral they are talking about. POST, they want us to prove that this is this is a cyclic quadrilateral. So having reminded about the properties of a cyclic quadrilateral, we probably realize that we can't prove the opposite angles to be supplementary, because we really don't have any information that can take us that way. Now, what are we having? For this to be a cyclic quadrilateral, we need to find out whether this angle is really equal to that angle, because now you can see that there are these lines that are drawn as diagonals of this quadrilateral. So if this angle is equal to that angle, then therefore this is just going to be a cyclic quadrilateral. Or maybe if it happens that this angle is equal to this whole angle here, which may not be easy for us to solve, but we can just find any pair, like for example this one. If it happens to be equal to this one, then therefore this is gonna be a cyclic quadrilateral. But I can only see one possibility here for US1 being equal to T2, because really OT from the beginning, OT was bisecting this whole angle PTS. It was being bisected this angle, so that UT1 was now then equal to UT2. So UT2 is equal to 1. Remember, in the previous question, we did prove that T1 is equal to S1. So if T1 is equal to T2, because the line being bisecting the other line, this angle, then therefore T2 is now, this is your T2, then now T2 is also equal to this one. Then therefore, because of these angles from the same segment, you can just reason by talking about what, by the converse theorem for angles from the same segment. So because these angles are equal to each other, so this is the cyclic quadrilateral. So I hope you enjoy the video, and see you in the next video.